So we'll move on to the next item on the agenda is the 2016 Regulatory Oversight Report for the Canadian nuclear power plants as outlined in CMD 17M15, 17M15.A, and 17M15.B. Again, we have a representative from the licensees, OPG, NB Power, Bruce Power, and Health Canada are also in attendance. And also, I understand that Mr. Morton of the Office of the Fire Marshal and Emergency Management is here. So thank you all for attending. And I will turn now the floor to CNSC staff. Mr. Frappier, you still have the floor.
Thank you very much, and again, good morning, Mr. President, members of the Commission. For the record, my name is Jerry Frappier, and I'm the Director General of the Directorate of Power Reactor Regulation. Today, I have the pleasure to present for information the 2016 edition of the Regulatory Oversight Report for Canadian nuclear power plants. The report, which hereafter we'll refer to as the Npp Report, summarizes the regulatory oversight and safety performance of Canadian nuclear power plants. Also, a supplemental CMD 17M15A.A has been submitted by staff providing status of actions from the Commission which have been addressed. That's something a bit new that was requested that over the year the Commission has asked us to do different things that we keep referring will come back to being part of the annual report. And so this supplemental CMD tries to put that all into a table format for ease of reference. The nuclear power plant report will be presented by management team and staff from the Directorate of Power Reactor Regulation. They are assisted by directors from the technical support branch and staff from that branch who are available to answer any technical questions the Commission may have. In addition, we have representatives from the licensees who are also present to participate in the meeting and provide additional information. But we would need the presentation on there now. Yeah. Great. Following an introduction that includes important background information, today's presentation will provide safety performance highlights of the nuclear power industry as a whole in 2016 and describe major regulatory developments. The presentation will continue with details regarding the safety performance and regulatory developments of individual NPPs, and I will then conclude with some general remarks. The Regulatory Oversight Report for Canadian Nuclear Power Plants 2016 is the first in a suite of regulatory oversight reports that the Commission will receive, and they will be presented to the Commission in the coming months. In the past, this suite of reports has included a regulatory oversight report on waste management, storage, and processing. The most recent report was for the year 2015 and was presented to the Commission in December of 2016. There will be no regulatory oversight report for that area this year. However, waste management facilities associated with the NPPs will be covered in the regulatory oversight report for NPPs starting next year in 2017. Moving to an introduction. In this introduction, we will provide you with some background information that is relevant to the Npp report, as well as some context for the industry and station-specific highlights that follow in the rest of the presentation. There are 4 operating NPPs in Canada. These include 3 multiple unit plants in Ontario and 1 single unit plant in New Brunswick. These 4 NPPs have operating licenses for a total of 21 reactors, and 19 of these reactors were operating during most of 2016. Units 2 and 3 at Pickering have been defueled since 2008 and continue to be in the safe storage state. Darlington Unit 2 was shut down in October of 2016, and it is the first unit at Darlington that will be refurbished, and that work is ongoing. I will now pass the presentation over to Ms. Kim Campbell.
Thank you, Mr. Frappier, and good morning, Mr. President and members of the Commission. For the record, my name is Kim Campbell. I am the Director of the Power Reactor Licensing and Compliance Integration Division. I will provide a background on the compliance verification program for NPPs and the public comment process conducted earlier this summer. Cnsc Compliance Verification Program uses a risk-informed and performance-based approach to verify that each NPP maintains compliance with all regulatory requirements in the regulations and the operating licenses. The program generates the results that form the basis of the safety performance ratings presented in the 2016 Npp Report. The Compliance Verification Program is composed of many activities that include surveillance and monitoring, inspections, and desktop reviews. Cnsc inspectors track all licensee corrective actions until closure and verify closure through follow-up activities. In 2016, Cnsc staff conducted a wide variety of inspections and submitted the results to licensees in a total of 90 inspection reports. These inspection reports are listed for the first time in the Npp Report in Appendix H. Npp licensees reported to Cnsc staff on 248 events in 2016, and Cnsc staff followed up on licensee corrective actions related to these events. The licensees also submitted 78 scheduled reports or periodic operating performance reports to the Cnsc. In all, 1,079 findings were derived from Cnsc's document reviews and inspections, and each of these were assessed by Cnsc specialists for the purpose of the 2016 Npp Report. This slide indicates the amount of effort in person days required from Cnsc inspectors and specialists to deliver compliance verification activities in 2016. These activities represent over 16,400 person days of effort by over 200 Cnsc staff. The largest category of work, other compliance activities, include station walkdowns, surveillance, desktop reviews of licensee submissions. In 2016, under the Auditor General Act, the Commissioner of the Environment and Sustainable Development conducted an audit of the Cnsc's site inspection of NPPs. The objective of the audit was to determine whether the Cnsc had adequately managed its site inspections of nuclear power plants to verify that the environment and the health, safety, and security of Canadians were protected. The audit found that when Cnsc inspectors identified issues during an NPP site inspection, they followed up with the licensee 100% of the time to ensure compliance. However, the report made 5 recommendations for improving the documentation of the NPP site inspection program. As you can see, all the recommendations have been addressed, and the Cnsc considers the audit closed. This slide highlights the elements that address the audit findings and are now integrated in the Cnsc's approved management system. The management system now stipulates that all compliance verification activities are to be completed using only formally approved procedures and tools. There are now established clear criteria for staff to use when determining when to conduct specific types of compliance verification activities. The management system now includes clear guidance for retention of records collected during compliance verification activities. It also establishes a clear process to develop our annual compliance verification plan for the risk-informed power reactor regulatory program. And finally, the management system sets out how Cnsc determines the number and level of site inspectors required to carry out our scheduled compliance verification activities using a resource allocation model in combination with risk analysis. A summary of the Npp report was posted on the Cnsc website with an invitation for comments on the report from the public and Indigenous groups. The posting was announced on the Cnsc website through social media and through the Cnsc email distribution list. In February of this year, the CNSC issued a notice of participant funding to 3 applications for participant funding which were approved by the Funding Review Committee. Independent Funding Review Committee awarded $33,362 through the Participant Funding Program to 3 recipients for participation in today's meeting. As a result of the posting, 7 interventions were received in total, 3 from the funded participants and 4 from other interveners. This slide details some of the CNSC responses to intervener comments that were received through the public comment process. The CNSC has decided to make alterations to this year's ROR based on some intervener comments regarding more inclusive wording to include all Indigenous peoples when referencing the public throughout the document. In addition, there were many thoughtful and well-informed recommendations in some interventions that the CNSC would like to explore further for possible inclusion in future regulatory oversight reports, with several examples listed on this slide. At the end of this presentation, CNSC staff have provided a table that summarizes the main points raised in these interventions and CNSC staff's responses to the comments and suggestions provided by the interveners. I will now pass the presentation over to Mr. Gracie.
Thank you, Ms. Campbell, and good morning, Mr. President and members of the Commission. For the record, my name is Brian Gracie, and I'm a Regulatory Program Officer in the Power Reactor Licensing and Compliance Integration Division. As summarized on this slide, CNSC staff have made the following general observations with respect to the safety performance of NPPs in 2016. There were no process failures of operating systems at any NPP that could have potentially challenged protective barriers. There were no events at NPPs that would have necessitated reporting to the IAEA, and none were classified as being above the International Nuclear Event Scale, or INES, Level 0. No member of the Canadian public received a radiation dose above the regulatory limit of 1 millisievert per year. There were no exposures of nuclear energy workers at Canadian NPPs above the regulatory dose limit of 50 millisieverts per year. There were no radiological releases from NPPs to the environment above the annual regulatory limits. In the area of conventional health and safety, the frequency and severity of injuries and accidents involving workers were very low. And finally, all licensees complied with their license conditions that addressed their nuclear security programs, as well as Canada's international obligations regarding the peaceful use of nuclear energy. Next, we have a tabulation of all of the ratings for the safety and control areas, or SCAs, and the integrated plant ratings, or IPRs, for the NPPs and the industry as a whole. Regarding overall NPP safety performance, the integrated plant ratings were fully satisfactory for Bruce A, Darlington, and Pickering, and satisfactory for Bruce B and Point Lepreau. At the SCA level, there were no ratings of below expectations or unacceptable, which was also the case for 2015. There were 19 SCA ratings of fully satisfactory, which was also the same as in the 2015 NPP report. The NPP report provides safety performance comparisons between the Canadian NPPs, and some of these involve comparison with international organizations. This slide shows the number of unplanned reactor trips, which are undesirable and unplanned power transients that cause automatic reactor shutdown by special safety systems. This parameter can be an indicator of how well an NPP is operated and maintained. The number of unplanned reactor trips for the Canadian NPPs is shown in purple, in comparison to values published by the World Association of Nuclear Operators, or WANO, in blue. Also shown as a red line is WANO's target of 0.5 unplanned reactor trips per 7,000 hours of reactor operation. 7,000 hours is the number of hours that a reactor would typically operate in an average year. The target of 0.5 applies to boiling water reactors, pressurized water reactors, and light water-cooled graphite moderated reactors. For pressurized heavy water reactors, or PHWRs, of which the CANDO reactors at Canadian NPPs are a subset, the WANO target is actually larger at 1 unplanned reactor trip per 7,000 hours. Canadian NPPs compare very well with both those targets. Note that WANO no longer publishes its data for unplanned reactor trips in the same format as in previous years. For 2016, it only published percentages of reactors that met targets instead of publishing actual data. Therefore, a comparison with actual WANO data for 2016 is not shown. We would also like to report that the data related to unplanned reactor trips in the NPP report contained an error. The number of hours of operation for 2016 for Point Lepreau in Table 5 in the report should have been 7,241 and not 26,339. Because Point Lepreau is only one of 19 operating reactors in Canada, it did not make a very large difference in the results. However, the graph on this slide that you see is noticeably different from the one in Figure 3 of the CMD itself. Table 5 and Figure 3 will be corrected when the NPP report is published. This slide shows the annual dose to the public resulting from airborne emissions and liquid releases. Because the doses are very low, we have used a logarithmic scale. The 5-year trend at each NPP continues to be consistently very low. Overall, the radioactive releases from Canadian NPPs result in a public dose that is about 1,000 times lower than the 1 millisievert public dose limit, which is shown by the red line. This data confirms that Canadian licensees' programs continue to be effective in protecting the public and the environment from radiological releases. NPP licensees monitor the occupational doses received by workers. This graph shows the 5-year trend in multicolored bars for annual dose distribution among all workers at Canadian NPPs. More than 3/4 of Canadian NPP workers received an occupational radiation dose below the minimum reportable level. The bars on the graph at this lowest of dose levels indicates that the number of workers in this category continued to rise during 2016. A total of 86% of the workers received less than 1 millisievert, which is actually the limit for a member of the general public. In addition, during 2016, no worker among the approximately 29,000 monitored received a dose exceeding the occupational dose limit of 50 millisieverts, indicated in red. This data indicates the continued overall effectiveness of the licensee's radiation protection programs in protecting workers in general and limiting the number of workers in the higher allowable dose ranges. Industrial safety accident rate is the number of lost time injuries per 200,000 person hours worked at the NPP, excluding contractors. The purple data in the graph shows that the rate has remained steady at Canadian NPPs in recent years. It also shows how the rate was significantly lower than average values published by WANO, indicating that Canadian NPPs have a good overall safety record in this area. Note that WANO no longer publishes its data for industrial safety accident rate in the same format, providing percentages of reactors that met targets instead of publishing actual data. Also, in 2016, WANO started publishing data that includes contractors. Therefore, a comparison with WANO data for 2016 is not shown. WANO's collective target for industry in 2016 was 0.2, and its target for individual NPPs was 0.5. The 2016 data for Canadian NPPs, individually and collectively, are well both below those WANO targets. The final graph for this section is for accident frequency, which is the number of disabling injuries per 200,000 person-hours worked at an NPP. A disabling injury is one that prevents an employee from reporting for work or from effectively performing all the duties connected with the employee's regular work. In 2016, the overall accident frequency for Canadian NPPs remains significantly lower than that of many other industries in Ontario and New Brunswick, and lower than that for the Cnsc itself. The data for WorkSafe BC is not yet available, and a comparison with other parts of the energy sector for 2016 was not possible because the Canadian Electricity Association stopped publishing comparable data for occupational safety in 2014. The next few slides describe some major regulatory developments that are applicable to the NPPs as a whole. I'll begin with a few highlights related to Periodic Safety Review, or PSR, which is being integrated with license renewal of NPPs. Periodic Safety Review is a systematic safety assessment of the design, condition, and operation of an NPP against modern codes, standards, and practices. It results in the identification of practicable safety improvements that can be executed over the course of a license period. Periodic Safety Review has now been effectively introduced at all NPPs in Canada, and the CNSC is using its updated requirements in Reg Doc 2.3.3 Periodic Safety Reviews. In brief, CNSC staff is reviewing Bruce Power's PSR submissions, which are linked to its next license renewal. Although the current operating license for Bruce expires in 2020, Bruce Power recently submitted its application for its next license to commence in 2018 to better coincide with reactor refurbishment at Bruce. OPG conducted an integrated safety review, which is an initial periodic safety review, in support of the refurbishment of Darlington and prior to renewal of its operating license in 2015. OPG is conducting a periodic safety review to support the extended operation of Pickering Units 1, 4, and 5 to 8 beyond 2020, in conjunction with preparations for its next license period expected to take effect in 2018. The Commission renewed the power reactor operating license for Point Lepreau for a period from July 1st, 2017 to June 30th, 2022. NB Power has already begun work on a periodic safety review, which would support the renewal of its next license, expected to take effect in 2022. License renewal establishes which particular set of regulatory documents and standards will be included in the licensing basis for an NPP. The Npp report describes the implementation of numerous updated and new regulatory documents and standards at each of the NPPs. Two examples are shown on the slide. Although many of these implementation plans are initiated in conjunction with license renewal, licensees also develop implementation plans for new and updated regulatory documents and standards during the license periods, that is, between renewals. License Conditions Handbooks, or LCHs, are maintained for all NPPs. They describe, among other things, the compliance verification criteria that CNSC staff use to assess licensee compliance with each condition in the operating license. These criteria include details of implementation plans for new and updated regulatory documents and standards. These license condition handbooks are regularly updated during the course of the license period as requirements, circumstances, and knowledge evolve. For example, NPP license conditions handbooks have been augmented by the inclusion of compliance verification criteria related to the topic of cybersecurity. In addition to various projects that involve updates to licensee programs to meet the latest updates of requirements. The licensees have other specific projects, including those to address issues related to the extended operation of their NPPs. As an example, Bruce Power and OPG cooperate on the Fuel Channel Life Management Project, which comprises research activities to study and quantify key areas of fuel channel behavior that may impact ongoing reactor operation beyond the originally predicted operational life. Both licensees are making use of new understanding of pressure tube fracture resistance to demonstrate their safe operation. Licensees are now examining tight-fitting spacers, which separate the pressure tube from the calandria tube in each fuel channel to demonstrate future fitness for service. Cnsc staff are satisfied with recent progress and will continue to monitor additional work that will be necessary to confirm safe pressure tube performance for later life conditions. The licensees conduct various assessments of the safety aspects and performance of their plants. Among them is Probabilistic Safety Assessment, or PSA, which is a comprehensive integrated assessment of NPP safety. It considers the probability, progression, and consequences of equipment failures or transient conditions to derive numerical estimates that provide a consistent measure of safety. All NPPs previously developed probabilistic safety assessments to address the requirements in Cnsc regulatory document S294. Cnsc has published updated probabilistic safety assessment requirements for NPPs in Reg Doc 2.4.2. NB Power is already compliant with Reg Doc 2.4.2, and the other licensees are in the process of transitioning to it. Licensees are required to update the PSAs on a regular basis. Cnsc staff was satisfied with the updates it reviewed during 2016 and is also satisfied with the overall progress towards compliance with Reg Doc 2.4.2. The area of emergency management saw several noteworthy developments during 2016. At the provincial level, provinces continued to update plans for nuclear and radiological emergencies that integrate with municipal and federal emergency plans, as well as the licensee's on-site emergency plans at each NPP. In Ontario, the Office of the Fire Marshal and Emergency Management is working with stakeholders on a review of the planning basis for the Provincial Nuclear Emergency Response Plan, referred to as the PNERP. The objective is to update the plan to reflect best practices, including new international recommended practices. The province solicited stakeholder input on a planning basis discussion paper from May 15th to July 14th of this year. It is expected that the revised plan will be submitted for approval in December. The New Brunswick Emergency Measures Organization is updating the New Brunswick Provincial Nuclear Emergency Response Off-Site Plan to align with CSA Standard N1600, titled General Requirements for Nuclear Emergency Programs. This update, expected to be completed in August, will also incorporate other national and international recommended best practices. The plan will be posted for the public. NB Power is also updating the documentation of the technical planning basis that is used for the off-site plan. Improvements at the emergency planning level are being complemented by technological enhancements that will also improve emergency management and response. For example, Cnsc staff has conveyed its expectations to licensees related to systems that can share plant data with Cnsc on a near real-time basis during emergencies. Cnsc staff accepted OPG's proposal to implement a new system by September 2017 and NB Power's proposal to implement its system by April 2018. Bruce Power currently shares data manually. Bruce Power committed to begin implementation of its DLAN data sharing application in 2017. This is discussed more in the Bruce part of the presentation. In another development, OPG is upgrading the emergency radio communication systems at Darlington and Pickering to ensure interoperability with those used by firefighters and police in the regional municipality of Durham. who support OPG's on-site fire response and security teams. Commissioning of the new radio system is planned for the end of 2017, and Cnsc's staff is satisfied with the progress to date. In addition to the improvements that have been noted, the licensees and Cnsc continue to conduct and evaluate emergency drills and exercises. Exercise Huron Challenge was conducted in 2016 and will be described in the Bruce part of the presentation. Future emergency exercises include one for Pickering in December 2017 and one for Point Lepreau in 2018. The Npp report provides information on the efforts of both the Cnsc and Npp licensees to engage Indigenous groups on matters related to their activities. The Npp licensees have dedicated engagement programs to sustain and enhance relations with Indigenous groups. Some of the licensees' information sharing events that occurred during the reporting period are listed on this slide. For its part, the Cnsc regularly communicates with First Nations and media groups and organizations. A key area is to share results and raise awareness of Cnsc's independent environmental monitoring program. Cnsc staff also set up an information booth at the General Assembly of the Métis Nation of Ontario in 2016. This concludes the industry safety performance section. We'll now present a summary for each NPP, consisting of safety performance ratings and safety performance highlights and regulatory developments. The safety performance highlights include both good practices and areas of regulatory focus. The regulatory developments include some details on major projects and initiatives. I'll now pass the presentation to Dr. Sanya Simic to begin with the NPP at Bruce.
Thank you, Mr. Gracie, and good morning, Mr. President and members of the Commission. For the record, my name is Sanya Simic, and I'm the Acting Director of the Bruce Regulatory Program Division. Bruce Power is licensed to operate the Bruce A and B nuclear power plants, each located on the shores of Lake Huron. Both plants consist of 4 CANDU units each. The Bruce site is the world's largest operating nuclear power facility in terms of output. In 2016, all 8 units were operational at Bruce A and B. In May 2015, the Commission renewed the Bruce A and Bruce B licenses as a single operating license. The new license is for a 5-year period and will expire in 2020. But, as mentioned already, Bruce Power is planning for an earlier application for license renewal. To support the major component replacement outages that will be part of the refurbishment project, Bruce Power has submitted an application to renew its operating license in 2018 for a period of 10 years. There was an event at Bruce in 2016 that was reported to the Commission in the form of an event initial report. At Unit 8 in February 2016, a worker doing maintenance on the generator rotor was drilling a hole when a flash occurred due to a hydrogen interaction. The worker suffered burns to his arms, chest, and face and was promptly transported to a hospital. The Ontario Ministry of Labour investigated the event and filed charges against Bruce Power. CNSC staff conducted its own reactive inspection and followed up to confirm the adequacy of corrective action. This event and the findings from CNSC follow-up activities are described further on a subsequent slide under the discussion of the SCA Conventional Health and Safety. The safety performance ratings in the Npp report took into consideration events and non-compliant findings from compliance verification activities, but also considered follow-up to them and the compliant findings that were identified during 2016. This table shows the 2016 safety performance ratings for the safety and control areas for both Bruce A and Bruce B. Any change in ratings for the SCAs will be discussed in the relevant sections over the next few slides. The net result in terms of the integrated plant ratings were fully satisfactory for Bruce A, but a decline from fully satisfactory to satisfactory in 2016 for Bruce B. for a detailed example of how these ratings are calculated and how even a small change in the underlying numbers can affect the plant rating, referred to Appendix B. A number of positive highlights are described in the NPP report for Bruce. First, the SCA operating performance was again a highlight, as Bruce Power continued to operate the site in a manner that met or exceeded the CNSC's requirements. There were no unplanned trips at either Bruce A or B in 2016, and the management of station outages was safe and effective. As just noted, the SCA rating for safety analysis increased to fully satisfactory in 2016, as CNSC staff concluded that Bruce A and B met or exceeded the relevant regulatory requirements, while transitioning to updated requirements. Bruce Power has an effective, well-managed deterministic safety analysis program and the outputs. For example, calculations of safety margins and predictions of the consequences of postulated accidents give confidence that the overall design is robust in terms of safety. Bruce Power is implementing Reg Doc 241, deterministic safety analysis, in a phased manner using a graded approach. While current probabilistic safety assessments meet existing requirements in Regulatory Document S294, Probabilistic Safety Assessment for Nuclear Power Plants, Bruce Power is also transitioning to Reg Doc 242, which has the same title, by June 30th, 2019. Finally, Bruce Power updated its criticality safety program in 2016, and CNSC staff found the program was compliant with CNSC Regulatory Document RD 327, Nuclear Criticality Safety. The results of CNSC's assessment of radiation protection at Bruce was also positive. Bruce Power has implemented a highly effective ALARA program, where ALARA means as low as reasonably achievable. CNSC staff observed that Bruce sets and achieves planned radiation protection goals, and that trends in results tended to be positive. There were no safety significant unplanned exposures to workers. Although the average and maximum individual dose for workers was higher in 2016, this was attributed to the type and scope of work being conducted rather than program performance. It was also noted that the estimated dose to the public from operations at Bruce was significantly lower than in 2015. The Bruce Power Nuclear Waste Management Program met or exceeded regulatory requirements at both Bruce A and B in 2016. All radioactive waste was disposed of properly and in accordance with regulatory requirements. Bruce Power continued to exceed regulatory requirements for conventional health and safety at Bruce A, as the rating remained at fully satisfactory in 2016. However, CNSC staff did have a specific focus on this SCA at Bruce B, where the rating decreased to satisfactory. CNSC staff conducted a reactive inspection related to the event involving the worker who received burns. CNSC staff found Bruce Power to be non-compliant with the requirement in CSA Standard N28605, Management System Requirements for Nuclear Power Plants, that requires the licensee to ensure that workplace hazards are evaluated, controlled, and the consequences of exposure to personnel are minimized. CNSC's follow-up determined that Bruce Power's corrective actions designed to prevent recurrence of such an event were appropriate and properly implemented. In the bigger picture, the accident severity rate and accident frequency at Bruce A and B were both acceptable and similar to the other NPPs. As suggested earlier, the accident frequency rate at Bruce in 2016 compared favorably with similar industries. The ratings for security changed from fully satisfactory to satisfactory from 2015 to 2016. CNSC staff determined the licensee continues to meet regulatory requirements, but did not demonstrate exceedance of regulatory expectations as in previous years, leading to the change. I will now switch to the topic of major projects and regulatory initiatives for Bruce A and B. As noted briefly already, Bruce Power conducted various activities for its periodic safety review that will support the major component replacement outages and the next license renewal for Bruce A and Bruce B. The main PSR outputs are the safety factor reports, the global assessment report, and the integrated implementation plan. CNSC staff are currently reviewing these results and will present them to the Commission during proceedings for license renewal of Bruce A and B. Bruce Power completed the implementation of the Environmental Assessment Follow-up Program related to the earlier refurbishment project for Units 1 and 2. While there is still a question about the threshold used for a deep water sculpin, the program has shown that there were no significant adverse environmental effects as a result of the refurbishment. A review of the final monitoring program report by CNSC and Environment and Climate Change Canada concluded that the refurbishment had no significant adverse environmental effects. However, discussions, including face-to-face meetings, have continued with Indigenous groups on fish impingement and entrainment-related matters. A technical workshop was conducted in May 2017 with Saugeen Ojibwe Nation. As a result of this workshop, a report outlining a proposed path forward for resolving each of the outstanding categories of issues is being prepared by an independent facilitator. Also, the CNSC hosted a Lake Huron-Saugeen Watershed workshop in June 2017 for the exchange of information on aquatic and fish-related matters. Participants included industry, government regulators, including CNSC, Indigenous groups, researchers, and other interested parties. Going forward, CNSC staff will continue to engage with local Indigenous groups regarding their concerns on a one-on-one basis. This last slide on major projects and regulatory initiatives for Bruce is related to developments in environmental protection and emergency preparedness. In 2015, Bruce Power assessed the need for an authorization from the Department of Fisheries and Oceans for impingement and entrainment of fish. Bruce Power submitted a draft authorization under Section 35 of the Fisheries Act to CNSC in September 2016 and a revised and completed application in May 2017. CNSC staff are reviewing the application and in June 2017 requested additional information from Bruce Power. CNSC staff have shared the application with interested Indigenous groups. If CNSC determines that the application is complete, it will advise Bruce Power to submit it to Fisheries and Oceans Canada with a copy provided to CNSC. The emergency exercise Huron Resolve was conducted in 2016 over a 5-day period. It tested Bruce Power's emergency response organization in a multi-unit accident scenario and involved over 30 organizations from all levels of government. It was an excellent test of measures that addressed a nuclear emergency that involved interactions among almost 500 participants. During its inspection of the exercise, CNSC staff identified some opportunities for procedural improvements in the Emergency Operations Center and identified expectations for an automatic data sharing system. In response to the inspection, Bruce Power committed to begin the implementation of its disaster land system for incident management in 2017, as described earlier. However, CNSC staff have determined that this system may not meet their expectation for the level of data sharing during an accident scenario. CNSC is following up with Bruce Power to ensure the data sharing meets CNSC expectations, in particular data collected and posted without human intervention and at a 15-minute interval or less. This concludes the summary for Bruce A and B, and I will now pass the presentation over to Dr. Miguel Santini.
Thank you, Dr. Simic, and good morning, Mr. President and members of the Commission. For the record, my name is Miguel Santini, and I'm the Director of the Darlington Regulatory Program Division. The Darlington Npp, operated by OPG, is located in Clarington, Ontario, and consists of 4 units. All 4 units at Darlington were operational during 2016, but Unit 2 was shut down in October to begin a long outage for refurbishment. In December 2015, the Commission renewed the Darlington operating license. With the new license, the Commission authorized OPG to undertake the refurbishment and life extension of the 4 units. The Commission also authorized OPG to operate the 4 units beyond the 210,000 equivalent full power hours up to a maximum of 235,000 equivalent full power hours prior to the proposed refurbishment outage. Besides the event that Bruce previously described by my colleague, only one other event that is relevant to NPP reports was reported to the Commission as an event initial report. It occurred at Darlington in 2017, but within the reporting time frame for the part of the NPP report where events are described. In February, OPG surveyed 4 motors that were to be shipped to a vendor for repair and detected no external contamination. Upon arrival at the vendor's facility, 1 motor was disassembled without incident. However, treated water was spilled when the second motor was taken apart. OPG provided equipment and personnel to decontaminate the facility. A qualified shipper sent the contaminated material and motors back to Darlington in accordance with packaging and transport requirements. OPG completed its investigation into the causes and used the results to confirm the corrective action that it had identified. Cnsc staff is satisfied with the actions taken to date. This table shows the 2016 safety performance ratings for the safety and control areas for Darlington. Any changes in rating for the SEAs will be discussed in the relevant sections over the next few slides. Overall, Darlington received an integrated plan rating of fully satisfactory in 2016. Darlington has received this rating consistently for the past 9 years since the integrated plan rating was introduced. A number of positive highlights are described in the NPP report for Darlington. First, the SEA operating performance was again a highlight in 2016. OPG continued to operate Darlington very safely and conducted licensing activities in a manner that met or exceeded Cnsc requirements. The management of station outages was safe and effective. Under SEA safety analysis, Cnsc staff concluded that Darlington again met or exceeded the relevant regulatory requirements while transitioning to updated requirements. Darlington has an effective, well-managed deterministic safety analysis program, and the outputs, such as predicted safety margin and consequences of postulated accidents, give confidence that the overall design is robust. OPG is implementing RegDoc 241, deterministic safety analysis, in a phased manner using a graded approach. While current PSA meets existing requirements in regulatory document S294, or probabilistic safety analysis assessment PSA for nuclear power plant, OPG is also transitioning to RegDoc 241, which has the same title by 2020. Under the SEA radiation protection, Cnsc staff found that OPG has implemented a highly effective, well-documented, and mature ALARA program. There were no safety significant unplanned exposure to workers, and the overall trend was positive. Doses to workers were below regulatory limits and below OPG's action levels. Cnsc staff also noted that the estimated dose to the public from operations at Darlington was low, with no negative trends observed. The results of Cnsc's assessment of waste management at Darlington were also very positive. The nuclear waste management program continued to meet or exceed regulatory requirements in 2016. The Cnsc staff is satisfied, is currently assessing OPG's latest submission of the preliminary decommissioning plan and financial guarantees for Darlington. One area of CNSC staff focus at Darlington is that of conventional health and safety, where the rating decreased from fully satisfactory to satisfactory from 2015 to 16. For example, CNSC staff observed non-compliance related to control and minimization of hazards related to confined space entry. Staff later confirmed that OPG's corrective actions were acceptable. CNSC staff identified other findings, such as those related to improper stored equipment, transient material, personal protective equipment, and scaffolding, and is monitoring OPG corrective actions. Another area of regulatory focus for CNSC staff is the interface between OPG's operating organization and the separate refurbishment organization as it relates to the safe operation of Darlington. These separate organizations require close coordination as they interface at various levels and share some common goals. For example, some deliverables in OPG's integrated implementation plan are managed by the operating organization and tracked by the refurbishment organization. Transfers of licensee staff from one organization to the other can help to receiving side, but transfer of experienced staff members to the refurbishing organization can impact the operational side. CNSC staff oversee these interactions in order to confirm that OPG's responsibility for safety is effectively discharged. I will now switch to the topic of major projects and regulatory initiatives for Darlington. The operating license for Darlington includes license conditions related to the refurbishment project. One of these conditions requires OPG to complete the integrated implementation plan for the refurbishment, which was approved by the Commission during the license renewal proceedings in 2015. An important component of the plan is the follow-up program to the 2012 environmental assessment. This includes safety improvements that address potential conditions during beyond design basis accidents. Other follow-up activities include aquatic sampling of thermal monitoring plan for long-term operations. A separate license condition requires OPG to implement its return to service plan, which details its control of the steps to confirm completion of the planned work. Another license condition establishes regulatory hold points that must be satisfied before the CNSC can approve return to service of each unit. These hold points apply at distinct phases of the commissioning of the units as they prepare to return to operation and allow for verification of each unit meets regulatory requirement at each stage. OPG began the refurbishment project with work beginning in Unit 2 in October 2016. CNSC's oversight, which includes specific compliance verification activity appropriate to the work being done, is progressing simultaneously. These graphs illustrate how the CNSC staff compliance verification effort will ramp up as the refurbishment project proceeds, reaching a maximum when as many as 3 reactors could be undergoing work simultaneously according to the current plans. The maximum number of refurbishment-related inspections is anticipated to be greater than 30 per year. To put this in perspective, Appendix H of the Npp report lists 29 CNSC inspections that were carried out at Darlington in 2016. This concludes the summary for Darlington. I will now pass the presentation over to Dr. Viktorov.
Thank you, Mr. Santini. Good morning, Mr. President, members of the Commission. For the record, my name is Alex Viktorov. I am the Director of Pickering Regulatory Program Division. The Pickering nuclear power plant is operated by Ontario Power Generation and is located in Pickering, Province of Ontario. The Pickering site consists of 8 units, 6 of which were operating during the year and 2 were in safe storage. The current operating license for Pickering is in effect from September 2013 and will last till August 31st, 2018. It is expected that OPG will submit the application for the next renewal of the operating license by the end of this month. This slide shows that Units 2 and 3 are in safe storage and that Unit 1 and 4 have been refurbished in early 2000s. This table shows the 2016 safety performance ratings for all of the safety and control areas for Pickering Nuclear Power Plant. A change in ratings in one essay will be discussed later on in the presentation. Overall, the integrated plant rating for Pickering remained unchanged at fully satisfactory in 2016. A number of positive highlights are described in the report for Pickering Stage based on the conclusions of Cnsc compliance work. As it was for Darlington, the safety control area of operating performance was an example of strong performance. OPG continued to operate the Pickering plant safely and conducted licensed activity in a manner that met or exceeded Cnsc requirements. Also, Cnsc continued to maintain a robust program to manage accidents, including severe accidents. Under the safety control area of safety analysis, Cnsc staff concluded that Pickering facility continued to conduct activities in a manner that met or exceeded the relevant requirements. Like Darlington, Pickering has a well-managed safety analysis program. Its outputs give confidence that overall plant design and operation are robust. Currently, OPG is implementing regulatory document 241 deterministic safety analysis in a phased manner and using a graded approach. While the current probabilistic safety analysis meets requirements set in regulatory document S294, OPG is implementing a new regulatory document 241, just like Darlington. Of note, the work on the whole site probabilistic safety analysis for Pickering facility piloted by OPG is considered a leading-edge development in the Canadian industry and indeed worldwide. Under the safety control area of conventional health and safety, OPG Pickering met or exceeded Cnsc requirements and provide effective personnel safety and safe working environment as demonstrated by multiple positive findings from Cnsc staff verifications. One example of improvements in this safety control area in the past year was installation of new monitors for hydrazine. These monitors improve response time and detection limits. Cnsc staff observed that safety improvements are facilitated by OPG daily Pickering station alignment meetings, where key and emergent safety, human performance, and operational issues are discussed, documented, and communicated. We find that these meetings have contributed to improved safety awareness at Pickering. In terms of overall results for conventional health and safety, Cnsc staff noted that accident severity and accident frequency were very low for Pickering in 2016. Cnsc staff also reaffirmed that the waste management program for radioactive and hazardous waste met or exceeded Cnsc requirements. We find the program is highly effective in promoting waste minimization, segregation, storage, and handling. I will now highlight several areas where Cnsc staff maintains an increased oversight focus. For the safety control area of radiation protection, the rating decreased from fully satisfactory to satisfactory. This decrease is due to a finding from Cnsc inspection in the specific area of radiological hazard control. As was identified in a Cnsc inspection, fixed area gamma monitors were not calibrated on the annual basis as required by the Nuclear Substance and Radiation Devices Regulations. Moreover, OPG had not implemented timely compensatory measures in accordance with their radiation protection program when the non-compliance was initially identified. However, following the Cnsc inspection and initiation of regulatory actions, OPG promptly took measures to remove the non-calibrated monitors from service. I would point out that this finding only pertained to a deficiency with a specific kind of equipment. Despite this deficiency, Cnsc staff confirms through inspection that OPG continued to implement a highly effective and well-documented program to maintain radiation doses to workers as low as reasonably practicable. This program meets regulatory requirements and is based on industry best practices. In 2014, the Commission removed the regulatory hold point for continued operation from the Pickering license. At that time, a requirement was put on OPG to submit an annual update on, first, the agent management program demonstrating fitness for service of major components, and the detailed risk improvement plan. The agent management program comprised scheduled inspection of fuel channels, feeders, and steam generators. In 2016, OPG continued to inspect major components, and this inspection determined that such components were fit for service, and in particular, the mean diameter of the pressure tubes were within acceptable values, the highest hydrogen concentration in pressure tubes were within acceptable limits, the inspected feeders had wall thickness greater than the minimum allowable, and no steam generators exceeded the limits of tube plugging. Overall, Cnsc staff are satisfied with the results of major component inspections and confirmed that the equipment conditions met regulatory requirements. Cnsc staff are also satisfied with the current status of implementation of the risk improvement plan, and we know that the changes result in further reduction of the risk posed by facility operations. All Phase 1 equipment and modifications are implemented. Such activities stemmed from the Fukushima Action Plan and primarily aim to further reduce risk of severe accidents. Some additional enhancements to equipment or plan modifications are still ongoing. For example, installation of additional quick connect points for the mobile equipment to provide water to various plant systems, as well as a second storage facility for such mobile equipment. The completion date for these activities is later this year. Phase 2 of the risk improvement plan includes additional emergency mitigating equipment and plant modifications, primarily to provide further defense in depth by securing power supply to key systems. Procurement and installation are ongoing according to the schedule and will be completed in 2017. During the last year, Cnsc staff reviewed probabilistic safety analysis updates as provided by OPG and are satisfied with the results. As already mentioned, OPG Pickering is leading the industry effort to develop and apply the methodology for multi-unit probabilistic safety analysis. Now I will briefly describe 3 noteworthy developments related to the Pickering facility. First, OPG submitted its application to Fisheries and Oceans on July 5, 2017 for an authorization under the Fisheries Act. The decision on this application is expected by the end of this year. Second, to support the continued operation of the plant, OPG is conducting a periodic safety review. The results will also be used in the license renewal application Overall, Cnsc staff is satisfied with the program of the periodic safety review and anticipates completion of this activity in spring 2018. Finally, an operational safety review team, or OSART, mission was conducted at Pickering in September and October 2016. OSART reviews are organized by the IAEA and are conducted by international teams of experts. OPG made OSART available to the public on May 24, 2017. The OSART mission at Pickering identified 10 recommendations, 11 suggestions, and 8 good practices. OPG management expressed their commitment to address the recommendations and develop a corrective action plan. Cnsc staff will monitor implementation of any changes in the plant and its operation as arising from OSART recommendations. There will be a follow-up mission in 2018. This concludes the summary for Pickering Nuclear Power Plant, and I will now pass the presentation to Mr. Khwaja.
Thank you, Dr. Viktorov. Good morning, Mr. President and members of the Commission. For the record, my name is Hatem Khwaja, and I'm the Acting Director for Gentilly 2 and Pointe-le-Pro Regulatory Program Division. In the interest of consistency with the other presentations today, I will present the highlights of the Cnsc safety assessment results for Pointe-le-Pro. The Commission has already considered the safety performance of Pointe-le-Pro in detail during Part 1 and Part 2 of the license renewal hearings in January and May of this year. At that time, the Commission received a detailed presentation on Pointe-le-Pro generating station. So I will go through the slides 57 to 63 very quickly. These highlight the Cnsc safety assessment results for Pointe-le-Pro. I and other Cnsc staff members are available to respond to all questions on the presentation or the Npp report during the Q&A period. So Pointe-le-Pro was operational throughout 2016. The license renewal hearings held in 2017 consisted of Part 1 in January and Part 2 in May. The operating license was renewed in June 2017 for a period of 5 years. It will expire in 2022. This table shows the 2016 safety performance ratings for the safety and control areas, or SCAs, for Pointe-le-Pro. Any changes in ratings or of SCAs are discussed in the next few slides. Overall, the integrated plant rating for Pointe-le-Pro remained unchanged at satisfactory in 2016. A number of positive highlights are described in the Npp report for Pointe-le-Pro, and a few are detailed on this slide. There are two examples of areas where Cnsc staff conduct enhanced regulatory oversight are described here. So this slide and the next provide details on some key regulatory developments. In particular, NB Power expects to submit its application for a Fishery Act authorization by fall 2017. During the course of the current 5-year license, NB Power will conduct a periodic safety review, or PSR, in accordance with Reg Doc 2.3.3. NB Power has already submitted PSR basis documentation, which is being reviewed by Cnsc staff. So this concludes the summary for Pointe-le-Pro and closes the part of the presentation highlighting Cnsc safety assessment results and regulatory developments for each operating nuclear power plant in Canada. I will now turn the presentation back to Monsieur Frappier.
Thank you, Mr. Khwaja. For the record, Jared Frappier. In closing, I would like to provide a brief concluding remarks on CNSC staff's works and its assessment of the safety performance of operating NPPs in Canada, highlighting some key and ongoing safety improvements. The NPP report provides numerous examples of compliance verification activities that identify compliant programs and activities and good practices, as well as identify non-compliant situations and practices, and ensures that they are followed up by appropriate and effective corrective measures. The CNSC staff maintains close observation and oversight of operations at Canada's NPPs and intervenes as needed to ensure compliance with requirements and ongoing safe operations. The CNSC staff observed that all NPPs in Canada operated safely in 2016. CNSC has established numerous and comprehensive requirements across all SCAs, and the licensees were in general compliant with them. CNSC compliance verification activities were successful in confirming overall compliance and identifying specific non-compliances in various SCAs and at each NPP. The licensees conducted corrective actions in 2016 to address them, largely to the satisfaction of CNSC staff. Those that were not completely addressed at the time of writing the NPP report are being pursued by the licensees with ongoing oversight by CNSC staff. The net results of the licensees program and CNSC's oversights of the 14 SCAs was a strong safety record in 2016. Some obvious safety highlights include low doses to workers and the public, minimal releases to the environment, and few events that necessitated discussions in front of the Commission. Also, generally positive results were observed in other important areas such as security, safeguards, public information and disclosure, and Indigenous relations. In terms of CNSC staff summary safety performance ratings, I note that all NPPs had at least an integrated plant rating of satisfactory, with 3 of them attaining an integrated plant rating of fully satisfactory. All licensees received either satisfactory or fully satisfactory ratings in all safety and control areas. Thank you for your attention, and staff is available to respond to any questions as well as licensee representatives.
Thank you.